Okay, welcome back once again to all my dear students. Last time, in the last video, we had discussed about the work and the first law of thermodynamics, then enthalpy and first law of thermodynamics, right? And moles and first law of thermodynamics. As you all know that what is the first law of thermodynamics? That is the delta U equals to Q plus W. Now, if we discuss about the enthalpy, then you all know that delta H equals to QP. That at a constant pressure, the heat is released or the heat will be absorbed by the system, that is called the change in the enthalpy, right? And the last one, that is a mole, that is the delta H equals to delta U plus delta Ng RT. So all this, according to all these three different equations, let us, in this video we are going to discuss about some example related to all this topic. Okay, so let us start the example number 1. First one here, example 1. चलो पहला एग्जांपल देखते हैं. At 1 bar pressure, at 1 bar pressure, okay, the volume of the gas is 0.6 liter. The volume of the gas is 0.6 liter, right? If the gas receive 122, if the gas receive 122 joule, right, of heat at 1 atmospheric pressure, of heat at 1 atmospheric pressure, at 1 atmospheric pressure, the volume becomes 2 liter. The volume becomes 2 liter, right? Then calculate its internal energy. Calculate its internal energy. Okay. Now, first of all, here the relation will be given that 1 liter bar, that is equals to 101.32 joule. Okay. Now, first of all, let us see that the pressure is 1 bar. Okay. So write down here the initial pressure that is I can write down here pressure that is equals to 1 bar. Now, the volume of the gas is 0.6 liter. So initial volume, you can write down here initial volume, that is V1 0.6 liter. If the gas receive 122 joule of heat, means the gas receive 122 joule of heat. So Q equals to 122 joule, right? At 1 atmospheric pressure, the volume becomes, means the final volume that is V2, it becomes 2 liter. Understand? Now you all know that what is the work function? W equals to P into delta V. So I can write down here P, V2 minus V1. So what is P? That is a 1 bar. What is V2? 2 liter minus 0.6. So I can write down here 1.4 liter into bar. This is W. Now, if you convert this in the form of joule, why? Because the work should be in the form of joule. So that here I can write down that 1 liter bar, that is equals to 101.32 joule. So 1.4 liter bar, that is equals to how much? So I can write down here W equals to 1.4 into 101.32. So let us see that by calculating this, you can get what? So here I can get 141.85 joule. 85 joule. This is W, right? Now I have to find out. Now here it will be given that work is done. Here it becomes 2 liters. So the work is done by the system. Here I can write down that here work is done by the system, and that's why I can say that W should be negative. So I can write down here W equals to minus 141.85 joules, right? So it will be negative. Now what is Q? Q, that is 122 joule. Now according to the first law of thermodynamics, you all know that delta U equals to Q plus W, right? So put here Q 122 minus 141.85. Okay, so calculate this, you can get the answer. Okay, minus 19.85 joule. Understand? This is the change in internal energy. Okay, so write down. Okay, now let us see the next example. Next example, a specific volume of the water of ice and water are of ice and water are 1.089 and 089 and 1.0 gram per milli, right? Milliliter per gram. Okay, write down milliliter and gram inverse. So 1 gram, this much milliliter will be there at 273 Kelvin temperature, at 273 Kelvin for temperature. Okay, temperature, right? Now the molar heat of fusion of ice is the molar heat of fusion of ice is how much? That it will be given 6.025 kilojoule per mole, 6.025 kilojoule mole inverse, right? At 273 Kelvin temperature, at 273 Kelvin temperature. Okay, so and 1 bar pressure, and 1 bar pressure, right? Now if 90 gram of ice melt at if 90 gram of ice melt at 298 or 273 Kelvin temperature, 273 Kelvin temperature, and 1 bar what pressure, and 1 bar pressure. Okay, now water is at 1 bar pressure, water is produced at that temperature, water is produced at that temperature. Okay, then calculate the value of delta H and delta U, then calculate the value of delta H and delta U of ice, right? First of all, for the process of ice, not for the process, for the process. First of all, here it will be given that 1 liter bar, that is equals to 101.32 joule, right? So now let us see that what you have to do here. First of all, it will be given that the specific volume of the ice and water, यहाँ पे ice और water का volume दिया हुआ है, and temperature is given 273 Kelvin. Now here the heat of fusion of ice is this much, right? So here I can say per mole. So 1 mole के लिए यहाँ पे heat of fusion इतना है. So first of all I have to find out the moles, right, at a constant pressure. क्योंकि pressure देखो यहाँ पे भी 1 bar है और यहाँ पे specific heat of fusion यहाँ पे भी 1 bar ही है, right? So I can write down the moles of ice, but यहाँ पे ice का mass कितना दिया हुआ है 90 ग्राम. So first of all, then find out the moles of ice. Moles of ice, that is equals to mass. Mass means 90 gram, and what is the molecular mass? That is 80 gram per mole. Understand? So gram will be cancel out. So you can get what? So 5 moles. यहाँ पे क्या मिला हमको? 5 moles. Understand? Now when 1 mole of ice melt at a pressure, 1 mole of ice melt at pressure 6.025 kilojoule. What? 6.25 kilojoule heat is absorbed. Heat is absorbed at constant pressure. At constant pressure, यहाँ पे constant आएगा क्योंकि pressure constant है, right? So this much heat will be absorbed. So यहाँ पे total heat absorb कितना मोल दिया हुआ है 5 मोल. तो total heat कितनी absorb होगी? तो I can write down here that 5 multiplied by 6.025. तो यहाँ पे QP आएगा. क्या आएगा? QP. At a constant heat will be absorbed. That is called this much multiplication करो तो ये आंसर आएगा 6.025. So 30.125. 30.125 क्या किलो जूल. Understand? Now you all know that what is delta H equals to QP, and that is equals to 30.125 kilojoule, and you can also write down 30125 joule. ये क्या आया? Change in enthalpy. Understand? पहले तो enthalpy मिल गई, अब मुझे क्या फाइंड आउट करना है? तो डेल्टा U. तो डेल्टा U के लिए हमको इक्वेशन मालूम है कि what is delta H. I can write down here delta H equals to delta U plus क्या आएगा? तो P into delta V. P into delta V. अब डेल्टा U को सब्जेक्ट करो तो डेल्टा U equals to delta H minus P into delta V. Understand? Now to find out P into delta V, how to find out? यहाँ पे P into delta V that is equals to P V2 minus V1. तो फर्स्ट ऑफ ऑल यू हैव टू फाइंड आउट V2. V2 कैसे फाइंड आउट करते हैं? तो देखो पहले तो आइस का वॉल्यूम और V1 एंड वाटर का वॉल्यूम मैं V2 देता हूं. तो V1 इज द वॉल्यूम ऑफ आइस and V2 is the volume of water. So write down here that V1 that is the volume of ice and V2 that is the volume of what? Water. Understand? दोनों का वॉल्यूम है. यहां पे मैं लिख सकता हूं कि 1 ग्राम के लिए इसका ml कितना है? 1.089. तो यहां पे 90 ग्राम के लिए आइस का वॉल्यूम कितना होगा? तो V1 that is equals to यहां पे मैं लिख सकता हूं कि 1 ग्राम, पहले तो 1 ग्राम 1 ग्राम that is equals to 1.089 ml of ice is there, right? So I can write down here 90 gram ice that is equals to how much, right? क्योंकि यहाँ पे 90 gram ice will be given. So 90 multiplied by 1.089. So this we can get V1. कितना आएगा? देखो 98 ml. This is V1. Now put V2. For V2 I can say that 1 gram that is equals to 1 ml. So 90 gram of water that is equals to how much? H2O. So here V2 equals to 90 ml. Right? Now I can put here that you can get P into delta V equals to, यहाँ पे क्या आएगा? P तो 1 ही है. V2 minus V1, so 90 minus 98. So I can here minus 8. Understand? Liter into bar. Now you all know that 1 liter bar that is equals to 101.32 joule. So minus 8 liter bar that is equals to how much? So I can say here that P into delta V that is equals to minus 8 into 101.32. So put the value, you can get the answer. चलो कैलकुलेट करो कितना आएगा. यू कैन गेट यहां पे कितना आएगा माइनस, यस यहां पे देखो लीटर बार है तो मिलीलीटर में अगर हमको कन्वर्ट करना है, चलो ये ml में आएगा ना, सॉरी दिस विल बी इन द फॉर्म ऑफ ml, सो दिस इज आल्सो इन द फॉर्म ऑफ ml। तो ml को लीटर में कन्वर्ट करो तो लीटर में क्या आएगा, तो माइनस 0.008 लीटर बार। तो यहां पे मैं लिख सकता हूं कि माइनस 0.008, राइट। तो यहां पे देखो माइनस 0.008, ओके, into 101, so that is equals to minus 0.81 joule. Understand, this is P into delta V. Now you have to write down here, put the value, you can get the delta U. Now you all know that delta U, that is equals to QV, and that is equals to, what is that, the delta H minus P into delta V. What is delta H? Delta H हमको यहाँ पे मिला 30125 माइनस P इंटू डेल्टा V कितना मिला, तो माइनस 0.81 जूल, राइट। सो 30125 माइनस माइनस प्लस 0.81, इज इट क्लियर? सो यू कैन गेट डेल्टा U that is equals to 30125.81 and the unit is joule. Understand? So this is how you can find out the change in internal energy, right? So write down all these things. ओके, चलो नेक्स्ट एग्जांपल देखते हैं। ओके, नेक्स्ट एग्जांपल, द हीट एसोसिएटेड विथ कंबशन ऑफ लिक्विड, द हीट एसोसिएटेड with the combustion of liquid, what, benzene at constant volume is minus 3268 kilojoule per mole, 68 kilojoule mole inverse, right? Calculate the change in enthalpy, calculate the change in enthalpy, that is a delta H, right, when the reaction occur at 300 Kelvin, when reaction occur at 300 Kelvin. यहाँ पे R, that is a gas constant, it will be given, that is a 8.314 joule mole inverse and Kelvin inverse. Understand? और यहाँ पे इक्वेशन दी गई है, तो C6H6 it will be in the form of liquid, plus 7.5 O2 it will be in the form of gas. You can get 6 CO2, it will be in the form of gas, plus 3H2O, and it will be in the form of liquid. Now यहाँ पे देखो कि कैलकुलेट द चेंज इन द एंथैल्पी, यहाँ पे कांस्टेंट वॉल्यूम है और हीट दी गई है, तो डेल्टा U that is equals to QV and that is equals to minus 3268 kilojoule mole inverse. Understand? Right? तो यहाँ पे किलो जूल में दिया हुआ है तो जूल में कन्वर्ट कर दो, चलो, तो माइनस 3268 इंटू 10�3 जूल इंटू मोल इनवर्स। अंडरस्टैंड? अब हमको मालूम है कि चेंज इन एंथैल्पी, दैट यू ऑल नो दैट डेल्टा H इक्वल्स टू डेल्टा U प्लस डेल्टा NG and RT। Now what is delta Ng? That is, you all know that total number of moles of gaseous product minus delta Ng, that is equals to total number of moles of gaseous product minus total number of moles of gaseous reactant. Understand? So I can write down here this way that delta Ng equals to Np minus Nr. यहाँ पे देखो गैसियस का मोल्स कितना है 6 माइनस यहाँ पे 7.5 तो minus 1.5 moles. Understand? Put here, you can get the answer. Yes, delta H equals to, what is delta U? Delta U, you have to convert in the form of, so minus 3268 into 10 raised to 3 joule है, plus delta Ng, that is a minus 1.5 into R, that is a 8.314 into T. T means कितना टेम्परेचर दिया हुआ है 300 केल्विन, यहाँ पे देखो तो 300 केल्विन. Put the value, you can get the answer. Okay, what is the answer? That you can get minus 3271 point कितना आएगा 74 किलो जूल मोल इनवर्स, राइट. और जूल में कन्वर्ट करना है तो जूल में कितना आएगा, तो यू हैव टू नो दैट व्हाट इज द जूल. यहाँ पे जूल में लाना है तो कितना जूल, तो minus 3271,740 joule mole inverse. Understand? Right? So this is how you can calculate if the moles delta Ng. How to find out the delta Ng? That you have to know that the gaseous total number of gaseous moles of product minus reactant. Understand? Note down. चलो नेक्स्ट एग्जांपल देखते हैं. Okay, so next example, calculate the change in internal energy. Calculate the change in internal energy, right, of the following reaction, of the following reaction at 300 Kelvin. What? Temperature. And you have to take here R equals to 8.314 joule mole inverse and Kelvin inverse. Understand? यहाँ पे इक्वेशन दी गई है कि 2 कार्बन सॉलिड प्लस what O2 gas gives what twice CO2 gas. और यहाँ पे change in enthalpy, this reaction is exothermic, so I can say minus 110.53 what kilojoule. यहाँ पे देखो, पहले तो मुझे इंटरनल एनर्जी फाइंड आउट करनी है, तो डेल्टा यू, आई नो दैट डेल्टा यू इक्वल्स टू व्हाट, डेल्टा एच माइनस डेल्टा एन जी आर टी. डेल्टा एच दी गई है तो किलो जूल्स है तो जूल में कन्वर्ट करो, तो माइनस 110.53 इंटू 10⁻³ जूल. अंडरस्टैंड और नॉट? या तो फिर इसको किलो जूल में कन्वर्ट कर दो, तो अगर ये नहीं करना है तो इसको रब कर दो और ये जो R है उसको किलो जूल में कर दो, तो 8.314 इंटू 10⁻³ किलो जूल. अंडरस्टैंड? इज इट क्लियर? किलो जूल मोल इनवर्स एंड केल्विन इनवर्स, ये भी चलेगा, राइट. नाउ यहाँ पे डेल्टा एन जी दैट इज इक्वल्स टू एन पी माइनस एन आर। प्रोडक्ट का मोल कितना है 2, रिएक्टेंट का मोल कितना है ओनली 1, so you can get 1 mole, right? Now put the value over here, you can get the answer that delta U equals to, what is delta H? Minus 110.53 minus, यहाँ पे देखो डेल्टा N that is a 1, 8.314 into 10 raised to minus 3 and temperature दिया गया है 300 केल्विन। चलो फाइंड आउट करो। Okay, so delta U equals to minus 113.024, क्या आएगा? तो किलो जूल, तो यहाँ पे डेल्टा U, understand? So this is how you can find out the what change in internal energy. Note down. चलो नेक्स्ट एग्जांपल देखते हैं। In a process 701 joule of heat is absorbed, 701 joule of heat is absorbed by the system and 394 joule work is done by the system, right? What is the change in internal energy of the process? What is the change in internal energy of process? यहाँ पे देखो कि 701 joule of heat is absorbed. Absorb means Q, it is positive 701 joule, and 394 joule of work is done by the system, so W is negative minus 394 joule. According to the first law of thermodynamics, delta U equals to Q plus W. So what is Q? 701 plus minus 394. So 701 minus 394. So whatever you can get, this is a delta U, that is 307 joule. Right? This is called the internal energy. Okay. Let us start the next question. Next example. Chalo. That a system receive 100 calorie of heat. A system receive 100 calorie of heat. At that time 50 calorie work is done by the system. At that time 50 calorie work done by the system, right? Calculate the change in internal energy. Calculate the change in internal energy, right? यहाँ आप देखो 100 calorie of heat is received, that means it will be absorbed, so the Q equals to 100 calories, right? And 50 calorie work is done by the system. So I can write down W equals to minus 50 calories. Now we have to find out the change in internal energy, that is a delta U equals to Q plus W. Put here Q 100 plus minus 50. So 100 minus 50, so you can get 50 calories. Understand? This we can say delta Q. Okay. So this is how you have to calculate internal energy as well as the enthalpy, right? So in this video up to here it's enough. In the next video we are going to discuss some limitations are there, first law of thermodynamics, and then we are going to start the second law of thermodynamics. Okay, so thank you very much.